So, interesting day today. Facebook wants me to go work for them. Second time they've asked. Amazon keeps harassing me every couple of months too. I've heard bad things about working at those places, so I don't know. Anyway, this video is about how to monitor a node in a distributed computing environment. First, we need to create a node Python file. This is going to be a pretty simple script, so it'll be contained in this one file. I always put finish at the end to know if it's done executing or if it gets hung up for some reason. I previously created a class to parse arguments. It's simple compared to the package that's out there for Python. This script is going to have two arguments. One that will just check to see if the network drive is available. This will stop the execution of the main program if the drive isn't available. This happens inside the Windows batch script. The second command line argument is called heartbeat, basically a loop, checking the status of the node, any specific data points that you want to check. In my case, I just want to know the computer name, the IP address, and the status of the network drive for now, and the last time it updated. So here we are just getting the directory listing for the folder that needs to exist. If it doesn't throw any errors, then that path exists. If it does throw an error, the program will exit and return a 1 to the system, which we can check in the Windows batch script, and that will terminate the script. The termination of the script won't allow the main program to execute, so it'll just exit. But since I don't remember code off the top of my head, need to reference it from another script that has it, the check for the exit code. This ends up causing an error. The loop keeps creating another node heartbeat instance, but I fix it by moving the loop down. While it looks like I fixed it immediately, it actually took me a while to figure that one out. Here I'm raising an exception if the user doesn't provide any command line arguments. This will stop the script from executing because it's throwing an error, which we check for. A heartbeat code will store its results in the database, so I need the CryptoDB class, which I created a while ago. I start to write the SQL, but decide to create the database table first. It will just have the name of the computer, the status of the network drive, the IP address, and the last time it reported back to the status. If you want an in-depth look at how I create database tables, check out the video on Interactive Brokers API Part 1. But it looks like I forgot the insert time on the database table. I corrected it a little later in the video. Copying and pasting the insert statement is a lot easier than writing it all out. Then copying the update statement from an already existing file because I don't remember code off the top of my head. Then I realize I need to make the network drive check function. Anytime you start copying and pasting code all over the place, and it can be a function, you should make it a function. And since I don't want it to terminate the heartbeat loop, I need to create a try-catch block, then let each calling code block handle it the way they need to handle it. Doing some testing to make sure that the changes are working properly. So I implemented the heartbeat data points. I'm doing research in another window that is off screen. If it's something of interest to show that, maybe I should show that. I don't know if that's worthwhile. But I'm just Googling how to get the IP and computer name in Python. Then I create a debug statement to print out the expected results. And test to see if it's working. Come to find out there's some errors. Of course, there's always errors. I didn't properly check the parse arguments value because it returns a string and not a boolean. Maybe I should change that, but I don't want to because it's being used in a lot of places. And now it's reporting the information that we want. I had a sleep so that it only checks every 5 minutes. Don't need it checking all the time. It'll create a huge load on the database and on the local CPU, so don't want that. But here's a huge error. MySQL too many connections error. This sets off a red flag because there are 40 nodes currently running and there's a script trying to update as well. So work on this node script comes to an abrupt halt while I track down this issue. Python and MySQL have a crappy way of handling the database connection. Pretty much everything handles MySQL connections poorly. But I've spent years making a well-designed database class for C#. I'm looking at porting it over into Python, but that's not on my to-do list yet. And it looks like this is a problem that has been going on for a while. This is why I need proper monitoring of a complex system. I had enough monitoring for version 1, but this is version 2 and I need to build it all up again. So I go through each of the nodes and check to see the status and how many have failed because of the too many connections error, then stop them from running if they're in an errored state. I go back to the database and adjust the max connection settings. It's a quick fix. I'll need to port over the database capabilities that I have created in C#. And this is a temporary fix because if the database restarts, this setting will need to be reset again. So I need to set it in the config file on the server. I'm checking one of the nodes to make sure that it can execute without having the database connection issues. Checking the other nodes, making sure they are not having this problem after the change, and starting the ones that I stopped, then checking the number of connections and seeing that they are staying well below the max. So back to writing the node script and testing to make sure it's writing to the database, which it is. But this is where I realize I need to capture the time, so I'm adding that to the database table. Running it again and watching it throw a bunch of errors. Because I didn't include the package, running it again and it throws an SQL error. which turns out to be a simple syntax fix. And running it again. Checking the database table to see if it's saved. And we have our results. Now that it works, time to check in the code changes and deploy it to the nodes. But GitHub has changed the way it manages user logins. So I end up spending the rest of the day trying to fix that issue. This is the fix. Basically set the remote URL with any username, then set the personal access token as the password within that URL. But you have to set the permissions on the access token as such. Then we can get back to setting up the node script. Here I'm going through each node and ensuring it's getting the latest from Git. Then running the node script to make sure it isn't throwing any errors, missing packages or the wrong version of package, because I was having those issues when I was dealing with the GitHub problem. After going through all the nodes, I noticed it was running twice or multiple times because it was inside the loop in the batch script, which I showed that fix earlier. I decided that I needed to ensure that only one instance of the script is running. So I'm writing a check to ensure that with ps utils. I'm able to get a list of all the processes currently running, but I only want the Python process that is running the node script. So I check for the executable, and then I need to check the command line arguments for the node script. I realize that the if statement is checking for the inverse and remove the not. I commit the changes, do some testing on the nodes, and realize that it's not running. And that's because the node script runs, then checks to see if there's any Python with node script running. And so the easy fix is to check to see if there are two instances of the node script running, not just one. I fixed that and everything looks to be working as it's supposed to. Mysql is updating with the status of each node, and I can easily see that one of the nodes doesn't have the network share, so I can log in and reconnect it without much effort, and that's it. So now I should be able to monitor nodes in a distributed environment or any computer on your network for whatever reason. So if you have any questions or suggestions, feel free to leave them below. If you enjoy this video and want to see more, make sure to subscribe. And if you want to help out, there are links to ways you can help fund this work in the description below. Thanks for watching. Until next video.